My name's John Hann. This is Brian Cavalier.
Hey, everybody.
I'm a UI architect at a small startup called LifeImage, and
I'm a web architect at a consulting firm in Pittsburgh called Hovercraft Studios.
and we're kind of partners in crime, trying to cause trouble in the JavaScript community in general. So this talk is to further that cause, actually. So just like a quick survey, how many people are using JavaScript modules today? Awesome. How many of those people are using them client-side? Or is that excellent? All right. How many people are familiar with CommonJS? How many people are familiar with CommonJS AMD? Yeah, are you using it today? No? All right. Okay, so we might have a little bit of time to talk about AMD in a little bit more detail, because that's kind of integral to this talk. So anyways, this talk is going to be about modules and why it's my personal mission and my belief. And I can't speak for Brian, because I'm going to be injecting a lot of my opinion here. I kind of dragged Brian along with me because we work together, about why modules, to me, are much cooler than frameworks. So at least my
I'm up here to refute everything John says.
Yeah, exactly. Okay, so first of all, what is a module? We just saw some modules with UE. There's actually some other talks about modules. By a strict definition from Wikipedia, modules are single-purposed. They're this compact unit of code, and they're pretty much self-contained. You can take that and move it around from one project to another. And very importantly, and this seems to get lost a lot, they're interchangeable. Like we saw in the previous talk, one of the most exciting things with modules today is the way that they can help speed up your application, and we just saw a perfect example of that with the UE loader. But I'm going to be talking about the exact opposite. That's a huge benefit with modules, but we're going to totally ignore that right now and talk about the coding benefits. So just a comparison, what's a web framework? And I tried to grab this off of Wikipedia as well, but it's kind of fragmented all over the place. Conversely to a module, which is this compact unit, a web framework is more multi-purpose, and it tries to commoditize services so that coding is easy. And one of the ways it does that is with an API abstraction and a set of built-in best practices. Say here's how you build an application with our framework.
So like if anybody uses Dojo, Dojo's a great example of a framework.
Or UE.
Yeah, or UE.
Yeah.
They have most everything you would need built in.
Right. So, yep. One of my biggest peeves with it is everything's globals with frameworks today. So then there's web libraries. jQuery is an example. What is a web library? It's kind of a small in a framework still. It's a globally available set of tools for you to use. Helps you get your shit done. It's bigger than a module, but not quite as big as a framework. Then we got these micro libraries and these micro frameworks, and it all gets kind of confusing. Like when do I pick one? When do I pick another? And it all comes down to the same thing to me: is just how much how much functionality do you get, and how much are you kind of forced into this framework. So, which is my biggest pet peeve here is that going with a framework or a library kind of locks you in, because you're coding to that library or framework now. And if you wanted to switch, the switching cost is extremely high, because you've coded basically around this framework, and the code infiltration is extremely high. So,
and not just how the modules work, but just even the names. If you're using something like Dojo, you do have Dojo dot throughout all of your code. So if you wanted to change any of that, you have that name littered through your code. So you would have to refactor all of that code too. Same with UE or any other large framework. Their namespaces are throughout your code.
So to me, this is kind of like coding dysentery. You know, it's just, you know, I just want to say, get your shit out of my code, you know. But you know, saying that, I really do like the frameworks. It's just when a client or my company says, okay, so why did you pick that framework? You know, it sucks at this, you know, and you know, I'd like to be able to say, oh, don't worry, we're going to switch that out for you. It's harder than it should be. So, and then on top of that, you know, you get the problem with the fact that, you know, you want to code to standards, you know, but you can't because you're stuck supporting these sucky old browsers. So here's an example of you know, some coding dysentery, and I'm going to pick on Dojo because Dojo is actually my #1 library that I pick. So examples here, you know, I got Dojo sprinkled all throughout my code. All right, and then to make it worse, I've got these non-standard calls to, you know, basically this is a wrapper around prevent default and stop propagation, right? So if I were to, there was some awesome new event-based library out there that does event handling way better than Dojo, then I know what you're thinking. So, but if there were, maybe there is, but I can't just swap it in for Dojo and expect it to work because my code is infiltrated with all these calls to proprietary, proprietary frameworks. And again, I'm not picking on Dojo here because this is the same with every library or framework that I've worked with so far. So. And if anybody has any questions or if I'm going too fast, I like to be interrupted actually because sometimes you remind me of something that I'm forgetting about. So if you have an intelligent question to ask, please ask it at any time. All right. Yes, I said intelligent. Yes. So, so what is the utopia? You know, what is, at least to me, what is a coding utopia? I'll have in my toolkit of dozens of standalone single-purpose modules. All right. Something I can take it. I can grab this best of breed here, grab this best of breed here, and assemble an application together. Again, as we saw with modules, they give you the opportunity to have small, fast code. They load, you know, really quick. I like to be in charge of my code, you know. So my code is my code, and then again, no globals at all. You know, I don't need to tell you guys about why globals shouldn't be in your code, but and sure they're namespaced, and there's all these no conflict type mechanisms so that the frameworks don't fight with each other anymore. But you know, just it's time we got rid of globals altogether. And in my coding utopia, I'll ignore IE 6 through 8. So here's an example of you know, this coding utopia. I'm using standard methods here. I'm using prevent default. I'm using query selector all. I'm using array iterators that have been available, at least in some browsers, since 1990, I don't know. So, and here's a second try. You know, here's maybe this is good enough. Instead of coding to standards, why don't we just agree on that there is a standard, but maybe we've had to wrap it to help support the older browsers, right? Because if we were going to work this way, this means duck punching the older browsers, basically prototype augmentation, which arguably is good or bad. If you're augmenting the prototype to a standard, I think some people think that's acceptable, but I think we've been burned so many times in the past. So maybe this is good enough. You know, if we just have some wrapper function that looks and behaves exactly like query selector all, or if we have this object with array iterators and array mutators on it that works and acts exactly like the standard, but instead takes an array as its parameter. So this kind of wrapper around arrays. Maybe that's good enough. And here's another example. We've got some event library here. So is this feasible? So in order to get this to work, we would have to have, #1, standard APIs. And again, my pet peeve, no globals. So, and again, you know, in order to meet this utopia, we need to be able to take these modules, because they've got standard APIs, we should be able to swap out for the best of breed.
And this last point is what we were mentioning earlier. When you have, when you just use a toolkit directly, and you're not using a module framework or a module loader that allows you to take control of the namespacing, you have things like UE and Dojo and you know, $sign sprinkled throughout your code, which makes switching harder. One thing that modules allows you to do, and with something like an AMD loader, if you've used one, you control the incoming namespace. So in the example that John just gave, the code example where he has event, add event listener, event is not a global. Event is something that we defined the name event, and we said, we want this module over here. Maybe it was written by someone, we found it on GitHub, it's really awesome. We pull that in, we assign it the name event. So that if we wanted to change that later, we control that name. We can say, okay, now I want this module over here, this event library, and I want to call it event. And because it's been coded to some standard API, you know, possibly a common JS API, it just works. We don't have to change the name here. We don't have to change the name of the methods. No refactoring. It just works.
Right. So that kind of gets in with this slide. What's wrong with this code? You know, it looks like we're still using globals, but we're actually not, and we'll show you in a minute why that we're not. But what else is wrong with this code? The W3C, you know, DOM methods, everybody's pretty sick of them. It's, you know, besides a lot of typing and whatnot, you know, it's just not a nice way to code. So we still got that issue to get around, and so there is a way to get around that, and we'll talk about it in a minute. So can we have these modules today? Not really. You know, people are still creating libraries, frameworks that use these global invasive ways to write your code, and swapping out requires standard APIs. And of course, JavaScript has no standard APIs. Well, that's not true, because it really does. And a lot of them are hidden, and I was surprised when I started digging in to find some of them. So, so for instance, just JavaScript itself, you know, ECMA, the forthcoming ECMA standards, some of them actually, I say forthcoming, but they're really here. It's just we're waiting for them to infiltrate the browsers. You know, arrays, objects, there's all these standard interfaces already. And we should start, well, actually, Dojo already does this already, and some of the other frameworks out there and libraries are doing it as well. Creating wrappers that actually mimic and look, you know, have the same parameter function signatures as the standards. So, and there are a bunch of others out there. There's JSON schema, JSON referencing, JSON path. Yeah, HTML5 and CSS3 give us some great APIs that we can model our libraries against. Query selector all, the event model, DOM. Again, those are quite ugly and unwieldy, but we can we'll see in a minute how we can address that. The REST is a de facto standard for web development. So there's some excellent APIs we can mimic for that. And plus there's CommonJS proposed standards. CommonJS it's not a dictatorship that says this is the way you have to do things. The way CommonJS works is people propose things and people basically vote on it through popularity, and just, you know, by using these standards, one of them will come up to the top, or several of them come to the top and become de facto standards, and that's happening right now, and it's very active right now. We're seeing lots of things come out and pop out as standards, well, potential standards. Sorry. Yeah,
and a lot of them are being used. I mean, they're on a wiki, on the CommonJS wiki, but a lot of them are being put into practice today. So this is going to happen more quickly than you might think. And a lot of these standards are going to become actual standards pretty quickly, I think.
Yeah, there's actually a lot of momentum, and of course the proposed standard that really helps us out on the browser side is asynchronous module definition, and I've got a great overview of asynchronous module definition at this this address here. We don't have time to go into all of it, of course, but I'm going to at least touch on it a little bit. So that's how I felt basically when I discovered AMD. Well, in a nutshell, it wraps our common JS standard module format, which is quite plain and simple. Again, we might be able to take a look at that a little bit if we have some time during this presentation, but I encourage you to take a look at that. It works today. No need to wait for all the current browsers to die. We can start using AMD. Actually, it's already being used in several places. And it has a migration path strategy. There's been several proposed strategies to migrate from AMD to JavaScript modules when it's available in ECMAScript. Definitely check out the 10 o'clock presentation tomorrow by Dave Herman about JavaScript modules and what they're going to look like when they really come to JavaScript. So. Unfortunately, the standards don't cover everything today. We don't have standards for templating. We don't have standards for data binding, application control flow. There's still a bazillion things we do on our apps that don't have a standard. So how do you deal with that? So there's plenty of ways to run around that, and I probably shouldn't say run around because they're actually very cool strategies. Brian later is going to talk about inversion of control and dependency injection. Interrupt anytime you want. So
I'm at 220, this room.
Yes.
Hear all about it.
So where places where there isn't no standard API, you can actually inject functionality or even use an observer or adapter patterns. And we're doing a lot of that actually in our projects where you build code that acts on your code and is not integrated into your code. So, and adapter patterns, these plugins can work in conjunction with IOC or in conjunction with module loaders in order to deliver additional functionality. So yes, we can have modules today. Here, very briefly, is the AMD module format. Your code, your actual module would go here. And basically the way it works is a single free variable. We don't call them globals anymore. We call them free. That's how we're getting away with this. There's a free variable. It's a function called define. And the first parameter to define, I'm lying, there's actually another parameter that can go in there, but don't use it. There's a way to identify your modules from within, but that's a strategy that's meant for the optimization, the concatenation, and the compilation pieces of AMD. So the first parameter is you specify a list of modules you want to pull in, and I'm pulling in something that looks like query selector all. I'm pulling in that array wrapper. I'm pulling in an event raptor. And I'm pulling in basically a promises library here. So here's an example of a plugin. I'm pulling in a text module, and I'm pulling in this proprietary CSS module. And I actually could just write that CSS here. I should have done that. So these are like standard plugins. So, and if you look closely, all of these map to function parameters here. Query selector all.
Here's where the names don't have to be the same.
Right.
The dependency names are actual names of modules on disk.
Actually, they're not here. They're not here. I remapped them already. So these could map directly to files in your web app, but actually there's a way to map them so that this query selector all could be actually pointing. Actually, right now in the project we're going to show, it's pointing at Sizzle, the jQuery selector engine, but we could easily just point it at Dojo's query engine or at NW Matcher, Diego Perini's query selector engine. And same with array. This is actually pointing at a small library I wrote, but it could be pointing at Uber's array wrapper. It could be pointing at dojo.array, or just the dojo object itself. So sorry, that was your brief introduction to AMD. I do have a whole presentation on that, and can show plenty of examples on how to build AMD-style modules. So bug me later today if you want to get a good intro into that. Here are the AMD loaders today. Require.js being the one that's been around the most. James Burke did an excellent job getting that going and getting that integrated, proposed to CommonJS. Chris Zipe had a big hand in that as well. Curl.js is the one that I wrote. Pinf by Christoph Dorn, thank you. BD Load, which is the one that was adapted to work with Dojo. That's by Roald Guild. There's even one that started up in Spain, LocalNet, and Dan Wright from Twitter is building one called LoadRunner.js, and from quick discussions with him, it sounds like he's also leaning towards AMD, or at least CommonJS format. And Kyle Simpson has been working on modular-based lab.js as well. And I've been arguing with Kyle back and forth. I think he's going to go AMD. So I don't think he has a choice, actually, because AMD actually has a lot of momentum right now. Firebug 1.8 is using it already. If you're using the Firebug alpha version, it's already using AMD formatted modules. Dojo 1.6 and 1.7. 1.6 is in release, and it's using AMD format. There's dozens and dozens of production apps out there. If you follow the Require.js Google group, you realize that there's just tons of people actually building production-worthy applications with it. And Open Cooperative Web Framework has also adapted it as their standard for modules as well. There's just tons of plugins out there. Oh, my links didn't work. CoffeeScript loaders, Google loaders, CSS loaders, CSS manipulators. You can load text, you can load translation files, you can load plain old JavaScript. I almost called it lame-o JavaScript. There's also lots of modules already available. Chris Zipe adapted Sizzle, which is one we're going to be using today. There's a ton. Peter Higgins has and Brian Forbes have created tons of modules you can use under the Uber GitHub repo. Brian's written some modules. I've written some modules. There's also lots of module helpers. IOC Wire is an IOC and version of control. What do you call it? What's it called? Framework?
Yeah, it's a inversion of control container. I'm a server-side guy turned front-end guy, so before you all sneer at IOC container in the server-side world, this is sort of a fresh take on it for JavaScript. If you're interested, come at 2:20 today and talk about it.
Yep, there's Has. How many people use Has.js? It's a way to feature test and fine-tune your modules so that only the code that's necessary gets shipped up to the browser. It's an awesome project. And then there's lots of other things in the works. I just named one of them here, Cola, to help deal with the other pieces that don't have standards. So that, again, Cola uses an observer pattern so that it doesn't infiltrate your code. We've almost got Utopia today. As you saw, UE uses modules, and they do an excellent job. They've got the performance thing down pat. Dojo is hot on their heels with 1.7. 1.6 is actually pretty good. 1.7 is going to be awesome in terms of modules. I've talked to some of the jQuery people about modules. They're looking at it. It'll come. So yeah, sorry, there's some examples of the Dojo ones that I think are the most awesome. I can just swap in a QSA if I want to, or deferred as a promise implementation. And the work Chris Zipe did on JSON REST, I think is an excellent example that we should be using for standard for server communications moving forward. But the big issue with Dojo and UE is it's still quite a commitment because just for instance, if you load Dojo's deferred, it pulls down an additional 20 files. Well, obviously you'd be compressing them, but you're kind of still locked into the whole Dojo thing as well. Okay, so I want to write a module. So here's a quick recipe. If you want to write a good module that anybody could start picking up and using, focus on a single purpose, minimize the number of dependencies so that a wider audience can adopt your module. Write some kick-ass code, of course, and follow the standards, even if it's just proposed standards. So, like, just about everything's a proposed standard if it's not in part of ECMAScript already, right? So innovate, obviously, without breaking the standards too badly. Or even if you have to break the standards, get some real-life code out there and get it out in production and propose a standard. If you're doing something that's awesome and lots of other people agree with you, or you think they should, get out there and propose a standard. It's not that hard, actually. The CommonJS blog is open for anybody to participate. So, actually, they probably hate that I'm saying this right now because they've been locked in their server-side world, and when us browser guys are starting to take over. So, and document where your module deviates from the standard. So someone picking up your module that you've written can know exactly what they need to do in order to make sure that they're not locking themselves in, and if they do, what they need to do in order to get around that. So.
And you may be doing something that goes above and beyond the current standard, and someone may choose to use that because it's awesome. And if you document that in your module, that might be a reason for someone to choose your module, especially if you're already out there, sort of pushing that extra functionality as an addendum to the standard or, a change to the standard. And one of the really cool things here, if you sum all of this up, it means you don't have to write a massive framework to get people to start using your code. You can write something really tiny, an array library, an implementation of the when function that's related to promises. Small things that you think could be really useful to people or that you're already using in your code. You can wrap them up as an AMD module, put them up on GitHub, tweet about them. People might start using them. If they're awesome, people will use them.
Exactly. Share it. Questions so far? Okay, so let's dig into the demo. All right. If I can find it. Oh, not good.
Does the green button work?
Green button. Zoom. It did. All right. All right. So we got a cute little application here. It doesn't do a whole lot. You basically have to pick which of these code snippets is more piratey than the other. Piratey being a good thing, by the way. Think of it as Ninja, but with a JSConf theme. Just demonstrate this really quickly. If I think this one on top is more piratey because, ooh, I like that. I like how that works. I'm going to choose that one. Ah, I should have done that. All right.
That's all right.
Sorry. But no, there's actually a performance problem with doing it this way, with this inline function, inline anonymous function. The JavaScript engines can't compile that effectively. So this one with the function hoisted is better. So that's not really what we need to talk about here. Really the flow is you choose something, you right or wrong, you click next. So you pick another one. Let's see. So which one of these is more piratey, the top one or the bottom?
Raise your hand if you think the top one is.
Oh.
Zoom.
Is that better?
Can you see now? Good.
All right. So I'm going to pick the bottom one. No, it was the top one. Sorry. So IMHO. Right. So let's take a look at the code here. This is our project. We have just a standard HTML file and several folders with modules in them. We've got this R library for our array. We've got this CSX module to load and manipulate CSS. We've got our AMD loader. We're using curl. And we've also, we're using wire for our inversion of control. And we've also got this view folder and this controller folder here that actually have our application code. And how this is laid out is just for simplicity. You can get really much more detailed with your folder structure. This is just so it's easily laid out here. So our views, we've got several views in here. Let me go back to the application here and show you how this is. We've got a codes view, a heading view, and a score view. Actually, the score view is hidden because we don't have that running yet. But this section up here, this is our heading view up here, this section of the application up there at the top. And our codes view is everything underneath. So this is its own view. So I'm using client-side views. So each one of these views is actually a component in our system. And each one of these components consists of 3 different files. A JavaScript controller, an HTML template, this is the pure view, and an MVC world. And we've also got a CSS file that's a companion to it. So, and again, the heading has, again, similarly, this heading component has a JavaScript controller, a template, and a CSS. All right, yeah, okay. So, let's see, I'll zoom that in for you guys. So, so here's a simple template with, it's just very straightforward. Zoom in here. All right, here's an example of us using an AMD-defined module. Our module itself is, this is really considered to be a wrapper. This is the part that one day when we have JavaScript modules, that's going to disappear, or it's going to morph into something that looks more like import statements. This is really the meat of our module down here. So down here, if you take a look, we're using almost entirely standard code. Actually, I take that back. We're actually using the wrapped ones in this version. I had another version that wasn't quite operational, where we were using what looked like standard DOM W3C event code. So this one uses these wrapped modules to add and remove event listeners, to do array iteration, and whatnot. And we've also got promises in there. Yes?
I'm curious about in the structure of how you're building that at the very top. You've got sort of one array, and then you're mapping that into the arguments. Why don't you have an object that's just sort of a name value setup so that somebody else coming along doesn't, that you're
going from vertical to horizontal, yeah.
In a way, could we somehow have this name value pairs in a way so that you really saw what was time for the other?
I agree, actually. This is something that takes some getting used to, and Kyle has been playing with this idea with different types of wrappers that may or may not make more sense to you. So he's gotten mixed reviews about his versions of this as well. But I definitely agree. Sorry, in case you didn't hear it, the fact that it's kind of hard to visualize the relationship between these dependencies and their the way they're basically quote imported as parameters into our module. So really quickly here, we just invented our own quick and dirty templating system here. It's just a replace of some tokens. This is actually a piece that can be abstracted out entirely, so it doesn't even appear in your code. So you're not actually manipulating your view inside your controller. They just kind of coexist happily. And as well, if you're abstracting the event delegation out, or the event handling out, again, this part down here also can get abstracted out of your code, and you're actually going to show an example of that at 2 o'clock, right? Yeah. Okay, cool.
Using an observer pattern external to the code itself to actually hook events together.
Right. So once you pull that out, the template out, and the event handling stuff, what you end up with is just pure business logic, and that I think is as close to the ideal as we're going to get. So let's take a look then at the main file. So here's the main HTML file. Standard HTML5, let's see. The first piece we want to look at is, this is the way to get the AMD loader kickstarted. We're saying that look for all of our modules, and the root of our modules is going to be in the JS folder. Here is where I insulted you by correcting you about where our files are located. We can actually tell the loader where to look for our files. For instance, wire is here. Our DOM ready, wherever we're referencing this DOM ready module, is actually looking for it here. Anywhere where it says CSS in our code, it's actually looking for it here, and we can see how these are mapped over here. So it's actually looking for anything that's called CSS, it's actually finding it here. And anything that's called DOM ready, it's finding it right there.
We tend to think of DOM ready as one of those things that is integral to a framework or a library, but as you can see here, it could just be a module too.
Yeah, and actually the AMD loaders are also taking this strategy that, yeah, no, DOM ready is its own module. So we're actually pulling them out and allowing people to pick and choose DOM ready, or use the one in your framework already, or use the one in the loader. It doesn't matter. And more importantly here, anywhere where we see a reference to query selector all, it's actually pulling in the sizzle engine right here, right there. And again, I could actually have mapped that to whoops. It's actually in this strange location. I'm not even sure if it's still here in 1.7, but I could actually map it like that, and that would work. And if I can get that running later today, I can actually show that. I've started working on a version that actually substitutes a lot of these things for dojos.
And because we used query selector all in the dependency list in our modules, we can make the change in one spot, and then everywhere we've imported query selector all, we get the new implementation. In this case, dojo.query, or a jQuery implementation,
right.
Or
and those are some great examples, because Dojo and Sizzle both follow the query selector all. They extend on it, and you can actually do additional things that weren't in query selector all. I might be talking on my ass right now, but they also do more than just the standard. And so again, that's something that needs to be documented, so you know when you're breaking the rules, so you know if what your switching costs are. So. And then here's an example of us using the wire plugin for AMD loaders to actually go and load our apps. So let's take a look at app loader. This is this code that actually bootstraps our app right here. This is the language of wire. So do you want to?
Sure. I'll give you just a quick rundown. This is just a module being defined using the free variable.
So a wire spec is just a module, right?
Yeah. So this spec is just a module, and this is basically an object literal that just describes all the components we want to bring into existence to make our app work. We have some data that we're loading from a module. We have our codes view, which you saw just a minute ago, and we specify the AMD module path to it, and some constructor args. In this case, a DOM node where we're going to stick that view. A heading view, which you saw has the picture of the two pirates. We're going to place that in the DOM also in the heading view container. The score view, which was hidden, and our controller. So we're just declaring what components go into our app, and where the views need to be placed. Our controller, we're injecting a reference to the codes view so that the controller can interact with it. So this is just sort of a declarative way to bootstrap our app and all its components.
All right. I think we're out of time. Is that correct? Are we out of time now? All right. But anyways, this is just a teaser about how Wire works in the version of control and how we're injecting other modules and properties into our modules. If you want to see more about this, 2 o'clock today, right? 2:20. Sorry, 2:20. 2:20 today here. So, any last questions? All right. Thanks for your time, guys.
Thanks, everybody.
Enjoy the rest of the conference.